Hello everybody, my name is Dr. Patrick Neumann. I'm a professor in the Industrial Engineering group here at Ryerson. My specialty is in human factors and the design of healthcare systems and supply chains. And the special skill I have is that I'm a cross-country ski instructor. So I hope to see you on the trail sometime. Take care. I think it's about the design of systems and processes, and it can be applied very broadly. We can talk about healthcare systems or operation systems in general, manufacturing systems. And anytime you have something that you're trying to get done, you have industrial engineering. Industrial engineers are used everywhere, so there's not a field that doesn't need industrial engineering. Whether you're figuring out how to manage your education system, or your healthcare system, or your factory, or your mining and resource extraction, even social systems, police services, all of those things can use industrial engineering knowledge in planning and designing systems that work better, are more reliable, are higher quality, better at retaining employees. All of those things exist in every operations. So students in my courses, they do projects all over the place. And that could be a cafe or a restaurant or a library or an auto repair center or a supermarket. Everywhere there's work to be done for industrial engineers. In the next 10 years, I think we're going to see a lot of development in robotics, in material sciences, and the things we can do with materials. This could be lighter, stronger. We're going to see a lot of Internet of Things type developments where devices learn to communicate directly with each other and respond appropriately. And a lot of data analysis. Big data is a fashionable term. So all of these high-tech developments are going to be going on. I think it's a question whether we're able to develop them in a way that's actually good for people, or whether we create systems that continue to be damaging to the environment and damaging to employees. And that's the challenge, I think, over the next 10 years and beyond. Environmental challenges are the big one. We're seeing just the very beginnings of what is going to be a very, very serious crisis globally. So that's one piece. I think the other piece is the well-being and safety of employees, and that we have 1 in 5 employees, so 20% of employees in Canada are suffering some kind of injury or illness because of work. And that then is an incredibly huge draw on the economy, on the scale of all cancers combined, but it's under-recognized and it's caused by the design of work. So it's a serious problem that affects a lot of people. Well, anywhere you have engineering design, you have ergonomics or human factors. To me, the words are interchangeable. Whatever engineering design you have, somebody has to build it, somebody has to install it, somebody has to maintain it, somebody has to use it, somebody has to dispose of it at the end of life. So people are involved all the way through, right? But if we don't take account of those people, then the systems will underperform. You're going to have human system errors, you're going to have quality problems, you'll have injuries. The systems just won't work the way you'd hoped. And so applying human factors in the design process to make sure that each stage of the life cycle is appropriate for the people in that stage and that they're able to do the job in a good way is essential to having an effective and efficient system. Of a system. I think anytime you have a system that's pushing people too hard, where they're fatigued, that's when you run into trouble, right? That when you're tired, you're not able to perform at the quality level that you might need. You're more likely to make errors, and that driving your employees into these fatigue states are going to lead to particularly inefficient systems with lots of quality errors, lots of waste materials, lots of garbage from stuff that needs to be thrown out. So those are the things you need to watch out for. Whether I can point at a given system and say that's a good system and that's a bad system is a lot more difficult because there are a lot of things that go into the system, right? So there's the physical design, there's the materials, the technology, the equipment, the layout, the work process. All of that stuff comes together to make the system. And so all of those things need to be coordinated in a good way if you're going to wind up with a good system. And that's the challenge of industrial engineering right there. So they're involved in various forms of modeling and simulation work. We're also creating new tools to help engineers identify human factors problems in their systems to improve quality, to improve injury risk, to understand what's good and bad about their processes, right? So do they have the appropriate approach to dealing with human factors in their development work? Do they need tools? All of these are things that my students might create according to the needs of our partner. So this is, we're using in a lot of ways conventional engineering approaches, but we're humanizing them, right? We're trying to make sure that we focus on the human and that the human aspects are appropriately considered at the right time, rather than after the injury or after the recall. Attending to your undergraduate education, right? Thinking more about the material and less about the grades, and trying to understand why you're learning these things. I think developing your communication skills and your ability to think about other people and listen to other people in different roles and different positions in the system is a huge, huge skill that's critical in terms of understanding the engineering problem. And then there's the technical skills and understanding how the technical design affects the people. And that requires both empathy and sometimes it requires methods. Simulation models, simulation tools, these are all super valuable. But the technical skills and the communication skills and the people skills are some of the most important pieces for professional engineers. Well, I think get engaged in your societies, start participating in elements that go beyond the class. And then as far as the classroom, develop your study habits. Treat it like a job, have your time off, but during the day or, during the work period, do your work and professionalize yourself as a student. And that'll make your life a lot easier. So you're not always thinking that you have to do your homework, right? You do your work during the day, you take your time in the evening. Maybe there's a few hours here and there, but working and recovering and having a life are all part of the game. And so the more you can start working on that balance now, the better you'll be all the way through your career.